right now there is this really persistent myth in the corporate world, that migrating to the cloud or shifting to virtual machines means finally waving goodbye to the messy reality of physical hardware and massive IT budgets.
Oh, yeah. It is a very seductive marketing pitch, honestly.
Thanks, babe.
The idea that infrastructure isn't a capital expense anymore.
Right. We tend to talk about virtualization like it's this weightless, frictionless digital frontier. Like, oh, you need a server to test a new application. You just log into a dashboard, click a button, and the infrastructure just materializes out of thin air.
Right, like turning on a faucet. You just tap into it as a utility.
Exactly. But today we're going to completely dismantle that illusion. Welcome to today's deep dive, where we are looking at an internal source document titled The Business Side of Virtualization, Budgets, and Governance.
And what becomes immediately apparent when you read through these materials is that every single time an engineer clicks Create Virtual Machine, they are making a highly complex financial and strategic decision.
They are essentially building the invisible architecture of the company.
That's a great way to put it. Yeah, because in an enterprise environment, a technical decision just cannot be divorced from a business decision. The budget dictates the technical reality.
And the technical reality defines the company's entire risk profile.
Exactly.
So whether you are prepping to lead a technical project or maybe you're trying to decode why your IT department operates like this strict intelligence agency with endless approval forms, or, you're just insanely curious about how the internet actually operates, this deep dive is going to completely reframe how you see tech infrastructure.
Because tech decisions are really business and ethical decisions at the end of the day.
They really are. Okay, let's unpack this. I want to start with a scenario from the sources that perfectly illustrates the hidden mechanics of cloud computing.
Oh, you're talking about the training department incident.
Yes. It is just such a textbook example of how quickly things spiral when governance is bypassed.
It really is. I mean, it's a cautionary tale.
So let's look at the mechanics of what actually happened here. You have this corporate training department, right? And they want to launch a new digital initiative.
But they know that submitting a request to central IT means waiting, like months for security reviews.
Right. Architecture planning, budget approvals, all that red tape. But they have their own departmental budget, and they just want to move fast. So they simply bypass IT.
What's fascinating here is that this is actually a known phenomenon. It's called shadow IT.
Shadow IT. Sounds ominous.
Little bit, yeah. It's when a business unit provisions its own technology resources completely outside of central governance. The friction of the traditional IT process pushes them to just seek the path of least resistance.
And the cloud makes that path incredibly easy. Like a couple of trainers who have some basic experience with Amazon Web Services, AWS, they just put a corporate credit card on file.
Which is always a dangerous move.
Oh, totally. Like handing a teenager a corporate credit card with absolutely no spending limit and dropping them in a candy store.
That is exactly what it's like.
So they log into the AWS console, spin up a dozen EC2 computing instances, connect them to S3 storage buckets, and boom, deploy a database. And for the first few weeks, it looks like this massive success story.
Right. They feel empowered. They're deploying code, testing features, completely autonomous.
But the infrastructure worked perfectly, right?
Oh, the architecture functioned flawlessly.
Yeah.
I mean, the computing instances processed the data. The storage buckets held the assets. It wasn't a technical failure.
So what happened?
The failure only materialized when the finance department received the invoices at the end of the quarter.
Ouch. And the bill was astronomical, wasn't it?
Just massive. It basically collapsed the project and forced the department to crawl back to central IT for a bailout.
But wait, let's unpack why that bill exploded. Because, the common assumption is that the cloud is intrinsically cheaper. Isn't the whole point of the cloud, like AWS or Microsoft Azure, that it's cheaper and more flexible than buying physical servers? Are you saying that's just a shell game?
Well, it's not a shell game, but it requires a fundamental shift in how you understand consumption-based billing.
Okay, how so?
So when you buy a physical server, your cost is fixed.
Yeah.
Right? It might sit idle for 20 hours a day, but you already paid for it. In the cloud, you are paying for microtransactions.
I see.
That training department, they probably just budgeted for the hourly rate of the servers. What they didn't understand were the underlying mechanics of cloud networking.
Like all the hidden fees.
Exactly. They were being charged for data egress.
Yeah.
So every single time a user downloaded a training video, they paid a fee. They were charged for API calls. Every time their application queried the database, fractions of a cent were tallied up.
Wow. So an automated script could theoretically provision 100 servers and generate millions of database read and write requests in a matter of seconds, and nobody has to sign a purchase order.
Precisely. The convenience of consumption-based billing creates unsustainable financial liabilities if there's no oversight tracking who approves what. The exact mechanism that scales your architecture instantly is the same mechanism that scales your financial liability instantly.
That is terrifying.
Yeah, without a governance framework tracking those automated triggers and without cost alert thresholds in place, you can bankrupt a project in days.
Because those hidden costs spiral so quickly, so companies can't just operate on the honor system. We really need to dissect what the sources refer to as cost pools, right?
Yes, cost pools are crucial. If we want to understand the true cost of virtualization, we have to look at where the money actually goes the second you hit Create VM.
Okay, let's start with the physical reality. Even if I'm provisioning a virtual machine, that software still requires a physical processor somewhere, doesn't it?
It absolutely does. The hardware cost pool is inescapable. Whether that machine is sitting in an on-premises data center managed by your own company or sitting in some massive hyperscale facility in Virginia, there is a physical piece of silicon doing the math.
Right. It's not actually a cloud.
Right. It's just someone else's computer. And that hardware has a life cycle. It has to be purchased, racked, cooled, and eventually replaced every 3 to 5 years during a hardware refresh cycle.
So when you use the cloud, you are simply paying a premium for the provider to manage that hardware refresh for you.
Exactly.
Okay, so the hardware cost is baked in. But let's look at the software side, because this is where the source document gets really interesting. A lot of enterprise environments run on open source operating systems, like Linux. And isn't that code freely available?
It is,
Yeah.
technically. But there's a famous IT quote from the source here, which is, free software isn't free at scale.
Okay, what does that mean in practice?
It's a really critical distinction. A single developer can run open source software on their laptop for free, but a Fortune 500 company cannot run its core transactional databases on, community forums and goodwill.
Right, they can't just post on Reddit if their banking app goes down.
Exactly. They require guaranteed uptime, immediate security patches for zero-day vulnerabilities, and dedicated emergency engineering support.
So they are essentially buying a massive insurance policy.
That's exactly what it is. They sign massive enterprise support contracts with vendors. So the capital that would have been spent on upfront software licenses is simply reallocated to the software cost pool as an ongoing maintenance fee.
Got it. But the sources highlight a massive trap here regarding lapsed contracts.
Oh, yes, the lapsed contract trap.
Yeah, like if a company is looking to tighten its belt and they decide, hey, let's skip a year of support maintenance on this virtualization platform because everything is running fine. I imagine the vendor doesn't just welcome them back with open arms when things eventually crash. Are we talking retroactive penalties?
Severe retroactive penalties is one of the most overlooked risks of virtualization budgets. If you let a maintenance contract lapse, and say 2 years later you need to upgrade to a new version to maintain compliance, the vendor will often force you to back pay all the missed years of support.
Wait, really? You have to pay for the years you didn't even use the support?
Yes. And they frequently tack on reinstatement surcharges on top of that. It completely destabilizes long-term virtualization budgets.
Wow, so you think you're saving money in year 1, but by year 3, you're paying a premium just to get back to the baseline.
Which creates version lock. The company decides they can't afford the penalty, so they just refuse to upgrade.
Yeah.
And that leaves them running outdated, vulnerable software.
Which increases their security risk exponentially.
Exactly.
That perfectly transitions into the operational and hosting cost pool, particularly the mechanics of vendor lock-in. Because we hear that term a lot, but how does it actually function mechanically in a cloud environment?
Well, it functions through architectural entanglement. When a cloud provider wants your business, they offer sweetheart deals in year 1. Deep discounts, free migration credits.
So year 1 looks incredibly cost efficient.
But once you are in their ecosystem, your developers start using the provider's proprietary tools, serverless functions, specific database architectures, native monitoring APIs.
Because it's easier and faster than building it from scratch.
Right. But by year 3, those discounts fade, and those proprietary tools do not exist outside that specific cloud provider. So migrating away becomes too painful.
It would require completely rewriting your software architecture.
Exactly. Furthermore, cloud providers structure their network fees to trap data. Ingress, which is uploading data into their cloud, is usually free. But Egress, downloading your own data out of their cloud, incurs massive bandwidth charges.
It's the classic Roach Motel architecture. Data checks in, but it costs a fortune to check out.
Yeah, that's exactly it. So when renewal time hits, the company just has to absorb these massive price hikes because the cost of migrating out is just higher than the premium.
That is wild. Which brings us to the final major cost pool, right? Labor and data management.
Yes, the human element.
Because there is this assumption that since virtualization and automation scripts handle the provisioning, the need for human labor decreases.
But the sources argue the exact opposite. Automation doesn't eliminate labor, it reshapes it. It shifts the requirement toward highly specialized, expensive engineering talent.
Right, because someone actually has to write the scripts and maintain the pipelines.
And troubleshoot when the automation triggers a cascading failure. Plus, there is a massive cost in internal labor, like training and dealing with burnout, and external labor, like hiring expensive contractors.
And if they try to save money by using contractors, they run into issues with institutional knowledge, right?
Exactly. A consultant builds a highly complex virtual environment, their contract ends, and they leave. 6 months later, the internal team has no idea how the underlying architecture functions. The institutional knowledge just evaporates.
This connects directly to the concept of data sprawl. Because virtual machines generate massive amounts of hidden data, right?
Oh, massive amount. Every time a system is updated, it takes an automated snapshot, like a complete copy of the operating system state. You have application logs, network traffic logs, configuration backups.
And if you don't understand the architecture, you don't know what data is actually valuable.
Right, so you don't have dedicated labor actively managing and pruning that data. You experience geometric storage growth. You end up paying enterprise storage rates to house terabytes of redundant, obsolete snapshots just because nobody on the internal team is confident enough to hit the delete button.
That is such a real problem. Okay, so we've established that the costs are omnipresent. You have hardware cycles, software penalties, vendor lock-in, and labor costs for data sprawl. Since these resources aren't infinite, someone has to play referee.
Yes, they do.
Here is where it gets really interesting. How does leadership prioritize these competing departmental needs? The source material illustrates this beautifully with a scenario called the Protocol 42 case study.
I love this scenario. It perfectly demonstrates the tension.
Let's walk the listener through the mechanics of this. Imagine you are the lead virtualization architect for a mid-sized enterprise. Leadership gives you exactly $100 in virtualization dollars. That is your absolute limit to build out an enterprise-grade environment.
Right, $100 total.
And you have 3 different departments aggressively demanding resources. First, you have the finance department. They manage the core transactional databases. They are demanding extreme high availability.
Because if their systems experience even a blip, customer transactions fail and the company bleeds revenue. Downtime costs millions.
Right. Second, you have research and development, R&D. They don't really care about a temporary server reboot.
Right. No, R&D needs massive compute performance and flexibility. They need to rapidly spin up test environments, run intensive data models, and tear them down quickly.
And finally, the Security Operations Center, the SOC, they want total network isolation, reliable storage for compliance, ensuring the audit trail remains untouched.
So you have a fixed budget. You can't give everyone premium SSD storage. You have to balance performance versus cost and redundancy versus efficiency.
How do you technically balance these competing demands without it devolving into a shouting match?
Well, you introduce the Change Control Board, or the CCB. It's the formal body that reviews, approves, or rejects changes to ensure fairness and prevent the loudest department from just monopolizing the budget.
Okay, but understanding that trade-off in your head is easy. Explaining it to a boardroom is the real challenge. Let's do a quick role play to demonstrate this dynamic in action.
Oh, sure. Let's do it.
I will play a skeptical, non-technical financial stakeholder who is looking at this massive proposed virtualization budget, and you play the IT director.
Sounds like my average Tuesday. Ready when you are.
Okay, here we go. So looking at this spreadsheet, I see we're spending so much on this so-called redundancy for the finance servers. But I also see that R&D is using standard cloud storage for a fraction of the cost. Storage is storage. Why can't we just use the same basic cloud storage the R&D team uses and save the company some money?
Well, I completely understand the need to optimize the budget, but we have to look at what we are actually purchasing here. We aren't just buying disk space, we are funding risk mitigation.
But the price difference is astronomical.
True, but the R&D storage tier is designed for flexibility. It lacks synchronous replication. If a physical array fails in the R&D cluster, the system goes offline for an hour. For R&D, an hour of downtime is an internal inconvenience. For prototype testing, they can tolerate it.
Okay, but finance.
For finance, our compliance framework mandates that we can never lose a single transactional record. A lack of redundancy in finance could mean violating compliance and losing millions in transactional downtime. The premium we are paying ensures our revenue stream remains uninterrupted. It is a strategic shield for the company's core mission.
Okay, scene. That was great. You beautifully translated the technical jargon into business risk.
Thanks. That is the exact defense an IT director has to make.
So what does this all mean for the people actually pushing the buttons? It's not just a financial equation anymore, is it?
No, if we connect this to the bigger picture, it's really an ethical equation.
How so? Like, how can simply spinning up a virtual server be considered an ethical dilemma?
Well, the sources outline dual dangers here regarding stewardship. The first is over-provisioning as waste.
Oh, like giving a server way more power than it needs.
Exactly.
Yeah.
Allocating more CPU or memory than needed feels safe to an engineer, right? You know it won't crash. But it's an ethical failure of stewardship. It wastes immense amounts of energy, power, and organizational money, contributing to environmental and financial bloat.
Right. Nobody ever got fired for buying too much server capacity, but it's wasteful.
Extremely wasteful.
But then, conversely, there is under-provisioning as a risk.
Yes, starting workloads to save a buck creates what we call normalized fragility.
Mechanically, how does that work?
If you don't give a virtual machine enough resources, it might run the main application fine, but it doesn't have the compute cycles to properly download background security patches.
Oh, wow. So a starved machine becomes a vulnerability.
Exactly. It becomes a fragile vulnerability that puts the entire company's and its customers' data at risk.
So IT professionals must really move beyond asking, can we do this, and start asking, should we do this?
Absolutely. They are stewards of both the financial capital and the operational integrity of the company.
So, to summarize all this for everyone listening, the next time you hear about a company moving to the cloud, you will know it is not just some magical cost-saving switch. It's a hugely complex balancing act of governance, hidden cost pools, and ethical stewardship.
It's the invisible architecture running the modern world.
It really is. But before we go, I want to leave you with one final provocative thought to ponder on your own. We've talked a lot about the dangers of human engineers manually scripting these environments. But right now, artificial intelligence is being integrated into these virtualization platforms.
Oh yeah, the AI auto-scaling.
Right. AI is being designed to automatically scale resources up and down based on demand. But who will be held accountable if the AI encounters a logic loop and provisions itself into a massive budget-breaking cloud bill?
That is a terrifying prospect.
If the AI is managing the invisible architecture, who is governing the AI? Who sits on the change control board for an algorithm?
That's the billion-dollar question.
Thanks for joining us on this deep dive, everyone. Keep asking those big questions.